we are interested in knowing VA1, which is the velocity of block A after the impact, the first impact. We'll multiply that by T by 2 to find out the total distance covered by block A. That is the ask of the question. So VA1 equals V0 minus 2VB1. That is equation number 1. We also know that the relative velocity of separation upon relative velocity of approach equals minus E. That E is called coefficient of restitution. For elastic collisions it's 1. So that means VA1 minus VB1 upon V0 minus 0 equals minus 1. So relative velocity of separation is VA1. So this is the diagram. After the first impact, this goes to the left direction, this goes to right direction, as you will see. So right now we are assuming that it goes to the opposite direction, because initial direction was in the positive x-axis side, V0. So if you don't want to put the directions, we can still put it VA1 in this direction, and you will see that it will turn out to be negative. So VA1 minus VB1 upon V0 0 equals minus 1. That means VA1 equals VB minus V0, VB1 minus V0. Okay, now what if we add equation 1 and equation 2? Or maybe not, because V0 will cancel out. Maybe we can just multiply this by 2, this equation by 2. Twice of VA1 equals 2VB1 minus 2V0. Now what if we add equation 1 and equation 1 3? VA1 to VA1, that is 3VA1 equals V0 to V0 minus V0 2VB1 get cancelled. So we have VA1 equals minus V0 by 3. Minus and indicates the opposite direction. So V0 is this, VA1 is this. So right after the impact it will go back. Therefore the distance traveled is equal to VA1 into T by 2. That is V0 by 3. We are taking the modulus, just the magnitude, into T by 2 is pi, equals V0 is 2 meters per second, 2 by 3 pi. Meters, of course, MKS units. So this was the ask of the question that appeared in the IIT exam this year. Now the fun begins when I try to conserve the energy here by putting an elastic wall, and the elastic wall is moved in a way that every time this block A hits block B, when block B is at the maximum stretch on the left hand side, that would mean block B would be at rest. I'm taking this because that way I have the energy conserved, and I can demonstrate in each collision how the energy is getting transferred, how each collision that block A makes with block B results in the energy seeping through to the harmonic oscillator. On in other way, the harmonic oscillator will suck in all the energy of this block A and will result in an enhanced or increased amplitude oscillations. So we'll see that next diagram.